communications terminology, computers are classified as data terminal equipment, and modems are called data communications equipment. So data terminal equipment, computers, is connected usually with an RS-232 serial cable to data communications equipment, a modem, which is then connected through a phone line to other data communications equipment, another modem, which is connected with an RS-232 serial cable to another computer, data terminal equipment. So there's actually 3 transmission speeds that are involved. There's the speed between the calling PC and its modem, which is called port speed. Then there's a speed between the 2 modems, which is called line speed or modem speed. And then finally there's the port speed between the answering PC and its modem. But no matter how fast all of these speeds are, there's another chip that has to be able to keep up. This chip is called the UART, and UART stands for Universal Asynchronous Receiver Transmitter. And this chip is responsible for any communication over a serial port and controls the speed as well as the other features of serial port communication. UART chips have evolved over the years as well, and UART chips are programmable through the operating system. We can control the buffer size and the port speed using Device Manager to configure the properties of the COM port that the modem is on. This will configure the UART. Additional controls through the UART are flow control, which is a method of controlling the flow of data by sending a message to stop data flow. In other words, it controls how computers communicate. In other words, when I'm going to talk and you're going to listen, and when you're going to listen and I'm going to talk. There are 2 methods by which computers communicate or control the flow of communication. There is a software method, which is X on, X off, and there is a hardware method, RTS, CTS protocol. There are advantages and disadvantages to each method. RTS-CTS requires the hardware to be able to be compatible with hardware flow control. But if the hardware is compatible, then hardware flow control doesn't take up any overhead in the transmission signal. Software flow control can be accomplished with the operating system and does not require that the hardware be able to do it. But the flow control signal is in the transmission signal, so the flow control signal takes up some of the bandwidth that we could otherwise use for data. Other properties that can be controlled with a UART include parity. In other words, will there be error checking or not? Stop bits. What will the code be to indicate that a character is starting or ending? And data bits. How many bits are to be used to send a signal or character of data? Most of the time we're going to use the default, which is 8 bits. But if all we're sending is ASCII code, we could use 7 bits to represent a character, and that would save space in our signal transmission. Most of the time when we install and configure a modem, we'll accept the defaults, and these properties will be set for us. But next we'll talk about how to install and configure a modem and the properties that we can set or have set for us, and we'll talk about that in our next section.